All right, today we're going to decode the feelings hidden all over the internet, buried inside millions and millions of lines of text. We're diving into how we can teach a machine not to feel, but to understand how we feel when we write something down. You ever stop and wonder about this? You leave a review on a product and bam, it's categorized. A website can tell you with confidence that, 85% of 10,000 comments are positive. How on earth is that possible? Is there some giant secret team of people reading every single thing we write online? Nope. The answer is something way, way cool. So what we're really talking about here is a technology that's kind of like a universal translator for human emotion. It's this hidden engine that powers so much of the modern web. And today, we're going to pop the hood and see exactly how it works. Okay, so the fancy name for this magic trick is sentiment analysis. You might also hear it called opinion mining. It's all part of a bigger field called natural language processing, which, let's be real, is just a complicated way of saying we're teaching computers to understand our language, not just the words, but the tone, the opinion, and the attitude behind them. And believe me, this isn't just some cool academic exercise. Sentiment analysis is absolutely everywhere. Companies are using it to sift through thousands of customer feedback emails in seconds. Brands are monitoring Twitter to see if people love or hate their new product launch in real time. It's how political campaigns get a feel for public opinion, and how shopping sites can filter reviews to show you the most helpful ones first. It's a truly fundamental tool for making sense of the mountains of text we all create every single day. So, to really get how this all works, we're going to go on a little mission together. We are going to build our very own movie critic, right from scratch. Our one and only goal? Teach a machine to read movie reviews and tell us if a film is a certified hit or a total flop. And this is our training ground. We're using a classic data set, 50,000 real movie reviews, taken straight from imdb. The task is super clear. A human has already labeled every single one of these as either positive or negative. Our machine's job is to read all of them, all 50,000, and start to learn the patterns. Okay, but here's the thing. Before our machine can learn anything, we've got to do some prep work. Think of it like a chef in a kitchen. You can't just throw a bunch of random ingredients into a pot and hope for a masterpiece, right? You have to chop, clean, and prepare everything first. It's the exact same idea with text data. Just look at the difference here. A raw comment from the internet is usually a mess. It's got HTML tags, weird punctuation, capital letters all over the place. A machine just can't work with that. So we clean it up, transforming it into this simple, standardized string of text. And notice this, we even kept the sad face emoticon. Why? Because that little guy carries a ton of sentiment. So here's the recipe for that cleaning process. First, we strip out any code and get rid of the punctuation. Then everything gets converted to lowercase so that movie with a capital M and movie with a lowercase m are seen as the exact same word. Next, we tokenize it, which is just a fancy way of saying we split the sentence into a list of individual words. After that, we take out all the stop words, super common words like the, or is, that don't really carry any opinion. And finally, we stem the words down to their root, so running and ran both just become run. All right, so our text is sparkling clean. But we've hit another wall. Computers don't speak English, they speak math. Our next and maybe most important job is to translate these clean words into the only language a machine truly understands, the language of numbers. And the classic way to do this is with a beautifully simple idea called the bag of words model. Seriously, imagine you take all the words in a sentence and you just toss them into a bag. The order gets all jumbled up, right? But you still know exactly which words are in there and how many of each you have. That is the core idea. We're not worried about grammar or sentence structure, just the vocabulary. Now let's see this in action. This is how that bag of words idea turns into actual numbers. First, we build a huge master list of every single unique word in our 50,000 reviews. Then, for each sentence, we create what's called a vector. We just put a 1 if a word from our master list is in the sentence, and a 0 if it's not. So a sentence like, "the movie was brilliant," becomes that numerical code you see right there. And that is something a machine can finally work with. Okay, that's pretty good. But you know what? We can make this even smarter. The bag of words model is a great start, but it has one little flaw. It treats every single word as equally important. And we, as humans, know that's just not true. Some words just pack a much bigger punch. I mean, really think about it, right? In a movie review, is the word "the" as important as the word "brilliant"? Is the word "was" as meaningful as "terrible"? No way. So our next step is to teach the machine how to spot the words that really matter. And we solve this with a really clever technique called TF-IDF. Now, I know it sounds super technical, but the idea behind it is actually pretty simple. It's basically a scoring system for words. It looks at two things. First, how often a word shows up in one review, and second, how rare that word is across all the reviews. This gives it a rarity bonus. So a word like brilliant gets a huge score because it signals a strong opinion and it's not in every single document. But a super common word like movie, which is everywhere, gets its score pushed down. This helps our model focus on the words that truly signal an opinion. Okay, this is it, the moment of truth. We have our clean, tokenized, numerical data. We've even given more weight to the important words. Now, we can finally feed all of this into a machine learning model and let it do what it does best, find patterns and learn how to classify things. And you know what? It actually works. We train a machine learning model on our 50,000 prepared reviews, and it learns the specific numerical patterns that mean positive and the ones that mean negative. Our movie critic is officially born. It can now take a brand new review it's never seen before and, with pretty high accuracy, tell us if it's a thumbs up or a thumbs down. But wait, hold on a second. This is where things get really, really interesting. So far, we've been telling the machine what to look for, right? Positive or negative? That's called supervised learning. But what happens if we don't give it any labels? What if we just hand it all the review text and simply ask it, hey, what are people talking about in here? And what it came back with? It's just incredible. Using a technique called unsupervised learning, the algorithm just started grouping words that tend to show up together across all those thousands of reviews. And look at what it found. Without any human guidance at all, it found these distinct clusters of words that clearly represent war movies, horror films, comedies. It literally discovered the concept of movie genres all by itself, just by reading. So think about what just happened here. The analysis went so much deeper than just a simple thumbs up or thumbs down. By just looking for statistical patterns in the language, the machine uncovered the entire thematic structure of the dataset. It didn't just become a critic, it almost became a film historian. And that really is the thought I want to leave you with. This whole thing started as a simple mission to classify reviews as good or bad, but it ended with a machine that could identify hidden topics and genres all on its own. It really makes you wonder, if a machine can learn this much from just 50,000 movie reviews, what other hidden patterns, what other big ideas are just waiting to be discovered in the vast ocean of words we create every single day?